Hi, welcome to an Arduino tutorial from Robojax. In this video I'm going to show you how we can control AC bulb or DC load and another AC load using Digispark USB development board, either this one or that one, to control it via a 5 volts relay. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with In many applications, you need to control a relay and also control an AC load or DC load. And using a large actual Arduino Uno or Arduino Mega will be a waste of money and space. And this is a perfect module that can do the job. Let me explain now this relay module. The relay module has 3 pins here. The first one is on this side, labeled as N. This is for input, where it receives the signal. Then we have the ground. This will be connected to the ground of Arduino module, and this is VCC. This will be connected to 5 volts. We have also 2 LEDs here. This red LED will turn on when this receives power, and the other one, when it receives the signal, it will turn on. When this is turned on, your relay will be energized and the load that you have connected will be turned on. For this project, you can also use this relay. The connection for the terminals are exactly the same. Negative is on this side, positive is at the middle, and input has been labeled as S or signal or off. We have 3 terminals here, and as you can see, this is labeled in Chinese and this is labeled in English. This is normally closed. If you connect your 2 wires in here, they will be normally closed, meaning without any power or anything, this wire will be connected to this wire, and your light or bulb or power will be switched on. And for your application, for our application, we will be connecting it in this 2-1, which is called normally open. So this is normally open now, and when the relay is energized and receives signal and power, this will connect these 2 wires. The same way for this one, except the label is in Chinese. So make sure to understand this. Either when this relay is turned on, your power is disconnected or connected. In any case, you have to connect 1 wire at the middle, and the other wire should be moved there. If you connect it here, your load will be turned off if this is on, and if you connect it here, your load will be turned on. So this is most of the case people will need to control and turn on. Now let me explain the wiring. Word of warning: once this is connected to AC, do not touch the relay, because this is a hot area and it will be very dangerous. And also make sure do not leave this relay on a surface that is metallic or conductive. This is a tabletop AC bulb, and this is a plug that you plug it into the wall and the device will turn on and off. And I have cut one of the wires of this, twisted them and soldered them, and this will be connected to relay. And the job of relay is to connect this and turn on the light, and this connected to turn off the light. The 2 wires that I shown you will be connected for the AC bulb to these 2 pins of a relay. For the relay, this is N. The N is connected to the first pin of Arduino, the pin 0, and then this green is ground. Ground is connected to the middle of Arduino board or Digispark board, and this is a VCC or 5 volts, which is connected to the last pin of this board. And here is how you can calculate the power rating of a relay. For example, this relay has been rated at 10 ampere at 250 volts, 10 ampere at 125, and 10 ampere at 30 volts DC, and 28 volts DC. In all these voltages, it has been rated at 10 ampere. But this one has been rated at 10 ampere 250 volts AC, 15 ampere 125, and 10 ampere 250. Regardless of which module you have, they all have a rating on them written, so keep that in mind. And this is a tiny version, and this is a smaller version. It has been rated at 2 ampere 30 volts, 0.6 ampere 110 volts DC, or 0.5 ampere 125. For all of this, you can find the data sheet from manufacturer and read it. For example, in your region, if you're controlling an AC load and the voltage is 220 volts, 10 times 220, just put a 0, it will be 2200 watts or 2.2 kilowatts. And if you're in North America, if it's 125 volts, for example, this one is rated at 15 ampere. So 15 times 120, you will get 1800 watt or 1.8 kilowatts. If you're using, let's say, 12 volts and 10 ampere, just multiply 10 times 12 volts, it will be 120 watts. So keep that in mind. But this is smaller. This can handle 0.6 ampere. If the voltage in your region is 220 times 0.6 ampere that this can handle, it will be 132 watt maximum that this can handle. If you overload any relay with a more than rated current, it will melt and there will be a hazard of fire. And if you want to go the other way, let's say you know the power and the voltage and you want to calculate the current. Let's say you have 1500 watt power and your region is 220 volts, 220. This can handle 6.8 ampere. So if you're using this relay, it is rated at 10 ampere, you're good. Make sure that the current that you calculate is always below the rated current, or the power that you calculate is always below the rated calculated power. Let me now explain the code. We define pin 0 as a relay. We call it relay, and throughout the code we will use this text keyword relay to refer to pin 0. And inside the setup, which starts from here and here, we just use pin mode. Let me turn this off. And using pin mode, we define relay, which is pin 0, as output. Then inside the loop, which starts from here to here, this code will run continuously. And this is just an example. You will change it accordingly for your own purpose. And we use digital write, which writes voltage to the output of the Arduino. We use relay. That means as if I type 0 and low. This means send low signal to the relay. This relay is low trigger and it will be turned on when it receives 0 volts. So that's why we put low, and then we keep it for 2 seconds. So this is not connected to AC. So this is turned on for 2 seconds and off for 1 second. Off is shorter. So we wait for 2 seconds and then we use digital write relay high. Now this pin 0 high, it will turn and off. So this and off will stay for 1 second. When this goes low, it waits for 2 seconds and turn off for 1 second, and the loop continues like that. We can change the time here. For example, if you want it for longer period or shorter, let's do it 300 milliseconds and then 300 milliseconds. Now to upload it, we have to disconnect our microcontroller and click upload. By the way, this works exactly the same with this one. For convenience, I'm using this one because the cable is easy for me. And we have 30 seconds window opened at this stage, connected. You will see upload done. And now it's 30 seconds, 300 milliseconds on, 300 milliseconds off. And for your application, if you want to turn it on, this is the on part. Let's say based on some action or something you want to turn it on. Here you can say if, let's say something, a temperature. If you have temperature, if temperature is bigger than 80 degrees, let's say this is a fan and you want to turn on a fan to cool up something. If the temperature is above 80 degrees Celsius, you want to turn this on. And after that, just close this and disregard this portion. I'm just showing you how to turn it on. If the temperature is above 80 degrees, the relay will be on. Else, you can say else which means otherwise turn it off. So this code will be there. So this way you can control your relay. Thank you for watching. This was how to use this Digispark USB microcontroller to control an AC or DC load. If you like this video and learned something, please thumb up. Please subscribe so you can get updates of my upcoming videos. If you have comment or question, post it at the comment section below the video. I try to answer and reply.